Welcome to this Disco project's demonstration of how we integrated our Urban Freight Data Space, or UFDS, with the URBANE project's user interface and model management engine to create innovative, user-friendly data space applications. The UFDS empowers our 8 participating cities to transition toward the physical internet. These include Ghent, Thessaloniki, Copenhagen, and Helsinki, shown here, alongside Barcelona, Padua, Zaragoza, and Valencia. These cities share critical datasets on traffic, deliveries, parking, and urban hazards. Beyond sharing, the data space streamlines structures via our vocabulary hub, enables discovery through our broker mechanism, and records transactions in our logging house. Crucially, and the focus of this video, it supports intuitive applications that unlock value from this shared data. For this demo, we use a delivery dataset from Copenhagen. This data is consumed through the data space via our connector and stored locally by a data app we call the data consumer. Finally, the URBANE platform utilizes this data to drive the locker placement simulation we will now explain. The Copenhagen test dataset represents a traditional door-to-door delivery schedule, essentially a manifest of tomorrow's deliveries for a specific area. We are simulating a single parcel delivery company whose warehouse is located here on the left side of the map. The application lets companies simulate switching from pure door-to-door delivery to a hybrid model. In this model, parcels go primarily to lockers or to the door if no locker is nearby. Setting up a scenario is straightforward. The user simply selects the number and type of vans and positions the lockers. The simulation then processes the delivery data. It assigns a parcel to the closest locker if one exists within a 500-meter radius. Otherwise, it defaults to door delivery. After the simulation, the user receives key metrics, including the percentage of locker deliveries, customer travel distances, and CO2 emissions. Users can also easily compare the results of different scenarios side by side. We start by logging into our demo connector. Browsing the catalog, we see all datasets available to us. We are specifically interested in GeoJSON datasets, so we use the search bar to locate them. After locating the Copenhagen test deliveries dataset, we must agree to the sharing terms. Since this is an open dataset, the process is straightforward. Once agreed, a new contract appears in the dashboard. We can now view the contract and initiate the data transfer using our data consumer application. Before transferring, we can rename the local dataset and add metadata, such as the city. For dynamic datasets, like those providing live traffic updates, we could also schedule recurring data retrieval. With the transfer complete, the dataset is stored locally. We can now access the URBANE platform to utilize it. Selecting the locker placement application, we enter the connection details for our data consumer app, enabling the platform to access the dataset. We are shown a map of participating cities in DISCO or URBANE projects. Copenhagen is now populated with the delivery data we just transferred. Selecting the dataset reveals the delivery points as blue dots. To initialize, we place the warehouse on the map. Then we configure the support vehicle for door-to-door deliveries. Finally, we set the number of locker delivery vans and the maximum distance allowed between lockers. Next, starting from the warehouse, we place lockers across the city. We do this by configuring the route for each delivery van, where each stop creates a locker location. Please note, portions of the video from this point forward have been sped up to facilitate narration. We repeat this process for the second locker delivery vehicle. With lockers placed, we click Calculate. The simulation completes in seconds, allowing us to view the results. First, however, we duplicate this scenario to create a second version. Here, we adjust the routes of the 2 locker delivery vans by placing extra lockers in the northern parts of the map, aiming to bring more customers within range. Once the second scenario has been calculated, we compare the 2 side by side. We can verify the locker placements and analyze the CO2 emissions, which account for Copenhagen's energy mix that is used to charge electric vehicles. Finally, we review the service metrics, including the number of locker deliveries and the walking distance required for customers. This concludes our demonstration of the Disco UFDS integration with the URBANE platform and model management engine. Thank you for watching.